My name is Derek Bevan. I'm an architect and an engineer and also the data science team strategist in Microsoft IT. My colleague, Val, I'll introduce.
My name is Fontama. I'm a principal data scientist in the DDSG team. DDSG is short for Data and Decision Sciences Group in MSIT.
Yeah, and as we were thinking about putting together this deck and trying to make it interesting and more informative to you, Val and I had a lot of conversations about the engagements we've had with CXOs, CIOs, our own leadership internally, and one of the recurring things that comes up is talking about data science, how it gets set up, how we do it, and such. And so what we're going to do is we're going to go through and we're going to highlight, give you an overview of how we frame the BI and advanced analytics conversation with our clients. We're going to share a little bit of our vision and our mission that we also share internally with our clients, and the 6 service lines that we light up that actually enable us to deliver data science as a practice inside Microsoft IT to the enterprise. In addition, we're going to talk about we'll talk a little bit about the team, how we the compositions of the team. We're going to share use cases, and Val's going to cover that, some of the use cases, and in one particular use case, we're going to go deep dive and give you an idea of how we go about solving one of our particular business problems that we have. Then we'll also discuss data science. That constantly comes up as a question, is what is a data scientist? How do you frame it? What do you do? Even internally inside Microsoft, we have this conversation. And then the other thing we thought was really important that comes up is how we engage, what's expected out of a stakeholder and client that you engage with as a data scientist. So one of the things we like to do right up front, because there's a lot of questions around what does a data scientist do? How does it differ from BI? So to light up that conversation, we're basically lifted from Gartner their actual analytic spectrum. And being an architect, I had to create a layer diagram here. And basically, the way it's framed in Gartner is descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. We then layer it down there with the roles that typically are associated internally at Microsoft so that they can have a frame of reference of where inside of least as far as the way we deliver it, how those roles relate to the various analytics places in the spectrum. And then lastly, down below is generally we find if we're dealing with descriptive and diagnostic, that ends up being in the BI enablement versus predictive and prescriptive, which ends up being advanced analytics the way we define it, and where our group, the DDSG, is actually located. And then enterprise data management represents all the data that we have to draw upon from all of Microsoft sources that we have. So when we think about descriptive, we're talking about there the type of things that our leaders would see that information workers actually bring to bear. That's self-service BI. You've heard a lot about the Power BI. That's used extensively internally inside Microsoft. These are the things that leaders look to. It's like scorecards. This is just basically the analytics around what's happened. Whereas the diagnostics kind of goes a little bit deeper. And inside Microsoft, you generally will have directors and we'll have middle managers that are having to make business decisions and investment decisions. And they will have on their teams IT professionals, business analysts, a little bit deeper knowledge workers. And they start doing more kind of like trending and such like that. So, and then when they get really to the point where they've exceeded the ability to actually, or they need deeper predictive and prescriptive analytics of what's going to happen, doing various simulations, or in the prescriptive set of things, actually bringing to bear not just the prediction, but when they have multiple options to choose from, our data scientists, since we have a purview across the entire enterprise, are able to bring in different data sources, different insights, and actually provide guidance, prescriptive guidance on how and which choices might work best for them. At the end of the day, it still is the business leaders, our leadership teams, decisions of which course they will want to take, but they're better informed with the insights that we're able to deliver. So this really tees the conversation up well. As every group in data science or even at Microsoft, we all have sort of vision. So our vision is actually to build a culture of data-driven decision makers. It's a good one. And we do that by providing advanced analytics. And we do that in the form of these 6 service lines. that we have. In IT, we've gone to the service model of delivering service delivery models across all of our service in IT. And so we've actually taken that from a data science standpoint as a data science team, and we've actually, this is how we do it. We put these in here. You might take these back to your organization and do it a little differently, but what we found that this works really well. The first three of these service lines are actually the data science practice itself. So when we're talking about strategic analytics consulting, simulation modeling services, big data analytics, the strategic analytics consulting represents the traditional analytics. It represents what's been done for eons, okay? That's the predictive, prescriptive, causality studies, fraud detection, design of experiment. We typically think of the strategic analytics consulting internally as really working on structured data. Those are the things that you'll see in SQL. It's already in PDW, very structured format. On the other half of our practice, we have the big data analytics, and that's dealing with, as you can see, social analysis, web media, you can deal with video, you can deal with a whole bunch of different things, but it's large-scale data, and that's your semi-structured and unstructured data. And in the middle, simulation modeling. We all have business systems that are very complex and costly to model or to get insights into, so we have simulation modeling capabilities in our team that allow us to actually model out supply chains and various type of business processes and test them out before we make those costly investments that our decision makers have to make. So that three is really the data science section. The big data innovation, this is where we take the algorithms, we take the data science, and we turn that into code and actually apply it into our systems that we have inside of Microsoft. So we'll run them on our Hadoop clusters, we'll run them in our PDWs. Also, as part of the engineering service in Microsoft and in IT, and probably most of your corporations, if you wherever you're at in IT, what we commonly hear is a lot of organic shadow applications spring up. We don't, at Microsoft, really frown on that as we used to many years ago. We kind of embrace it, and so there is a lot of shadow apps, and what the thinking around this is that there is a lot of times inside the organization and various parts of the business that there's a need to actually build out these solutions, and they have a very valid business case. And in prior years, they would go outside and use a third party to build this, and it would not connect up and things wouldn't match up, and then that would all end up back in IT that we'd have to own and have to try to fix and spend a lot of money. So we also offer solution design and architectural design consulting in our big data, and we will go and help work with different teams to help them design their systems. And there's an advantage to that because as a data scientist team, you want the data scientists, they're very expensive commodities and resources in an organization. You want them to be able to go and be able to work in another part of the organization and also come back and work in, say, in our data science org group and actually do design of experiments, do the POCs in an experimental environment, but then go over to say the line of business that actually has a large cluster and actually be able to deploy those algorithms into those spaces. As being good stewards and really as part of our vision is to drive data-driven decision making, we have an active, vibrant data science community. We put on a data science summit once a year that draws is only internally, and we do have some external customers that we do invite to those events. Last year we had Tom Davenport and Satya Nadella came and talked. Who knows that the reason for coming to our data science thing, he became CEO, I guess. That was kind of, I always like to joke about that, take credit. We do extensive data science training. We really believe in this. So our data scientists actually teach training classes that we've built internally to and offer internally to our FTEs. That's full-time employees, as you know. And also brown bags and speaker engagements. We really want to foster this culture. The other thing too is we realize that inside Microsoft, there's a lot, we are one data science organization, we are a central one, but there's also other data science organizations that are working on very singular, very specific problems that they're trying to solve, and they want to actually build out their own teams. And so we offer data consulting on that to help them figure out how to structure their teams in a right and smart way. And lastly, we have partnered with our Microsoft Consulting Services, our EPG, and a number of product groups to actually go out and help and work with customers out there, external. That's what Val's leading and heading up, and he'll talk about that a little bit later. And I think that's enough on that slide.
Okay.
Does anybody have any questions at this point or no? Good? Okay. Some of the industries our data scientists come from, there's actually, looks like there's 4 here, but there's actually, there's actually 5 on the slide here, and actually one other one. Telecommunications, telco, we have to have as a data science team, it's really a team sport effort. So we have on our team data scientists that have come from various different industries, at least the 6 of the 10 industrials that are out there: telecommunications, telco, finance and banking, healthcare, industrials, utility, corporate companies, and of course being IT and Microsoft, information technology isn't up here, but we do a tremendous amount of data science work within that space. Okay, so we're going to talk a little bit about the process here. We follow the CRISP data, I guess it's the
GM.
Yes, the model for how we actually do and build out predictive modeling. So we just kind of put this up here so that you can see. One of the things we start with, the one is to define the business problem. It's very important. The entire building of a predictive model starts with actually defining the model, and it ends with defining the business problem. Defining the business problem first, and then ending with resolving that business problem. To do that, we actually have a pretty extensive process that we call a project discovery process, where we meet with the clients, where we meet internally with different groups, and we do exploration for data. We find out what the problem is, we resolve it. The next stage is to getting the data. That's really a big portion of it. It's not the fun part, but our data science is really the grunt work. Our data scientists do get involved into getting into pulling the data and looking at the data and touching the data. There's a lot of questions that strangely come up when we're talking about with some different groups, that the thought is that data scientists don't get their hands dirty, that it's somebody else that does this. And what we found is that when we have data scientists that we brought onto the team that do not get into the data or rely on third party to go do that data exploration, pull it in, they're not quite as effective as they're really not as effective as they could be had they actually gotten into the data. So our data scientists get in and do the grunt work. Then it gets to the fun part, which is the developing the models, the thing that all the data scientists crave and want to do, and that's they will develop the model, they will work through it, they will iterate through this and train the model, they will meet with the client, and they will validate that the insights that are being seen are the ones that are actually the most valuable for them to make a good business decision. At some point, it always turns out that these models, some of them don't make it, but a lot of them get, by and large, do get deployed, and then they are monitored because, as you know, models are good for a duration and then they degrade, sort of like food. So you gotta kind of constantly go back and look at those models, and we have processes in place where when we are doing these, that we can go and continually look at these models, tune them, and help to improve them. Val will talk a little bit about that in detail. And then the process kind of starts over again. So if you're looking for if you're looking to start your own data science organization or thinking about even just doing predictive modeling, look up the CRISP model. We've taken a variation of it and applied it. We'd be glad to talk to you guys offline for those that are interested. I won't belabor this much. Okay. One of the things we want to share with you is that we are solving real problems. There's a sampling of these. There's too many to put on here. If you were in a great talk just a little while ago by Zoe Crum and Sanjay Sani, they talked a little bit about some of the work that our cybercrimes unit is doing. It's fascinating, and if you have a chance to go out and look at some of the websites and some of the information on that, there's a lot of information to glean about how piracy detection, but the botnets, and how we're bringing down and helping to make the internet safer, hopefully, and working together with police agencies and so forth. If you see the little elephant, those are really their big data type of projects that we worked on. We've done everything from Windows telemetry with segmentation and cycle time. Val is going to go and talk a little bit more about the ms.com targeting in detail. We have worked on churn models. We do a lot of churn models internally. Microsoft has a lot of properties that we have, and we really want to understand how we can really improve the customer experience. We really do try to do this, and we work really hard at it. And so we are engaged as a data science team by a lot of different groups in recently to do that. Now, I don't know if I mentioned, but the DDSG has been in Microsoft. The data science team has been in IT, and it's been operating for 4.5 years. It's one of the oldest data science groups in there, and I'll talk a little bit more later about how we structure the team after Val does some of the meaty stuff and interesting stuff around the use cases. And then security. We have, I think their talk covered mostly about honeypots and tracking down botnets and such. But Microsoft has one of the largest networks in the world, and it is a target. And so Microsoft IT has a group, the ISRM, the security group, that actually looks and monitors this, and they work with us to actually help create algorithms and models that are actually in place that go and actually analyze the traffic and actually catch intrusions. I think that's good enough for that.
Okay.
So I'm going to hand it off to Val and let him take over here.
Thanks very much for that a nice introduction, Derek.
Thank you.
So in the next few minutes, I want to go a bit deeper into some of the examples of real cases where our team of data scientists are actually using predictive models to solve hard business problems for Microsoft and our customers. I want to start with a really cool video about our digital cybercrimes team. Those of you who were lucky enough to attend Zoe and Sanjay's session next door just before this would have heard a little bit more about what they do. So let's just wrap up and see what they do and how what role we play in that solution. So
every year, criminals are getting more sophisticated in figuring out how to exploit the internet for purposes of doing harm to others.
These guys are really sophisticated. They're technology oriented.
It's everything from malicious code and computer viruses to child pornography and human trafficking to software counterfeiting, internet piracy, advertising fraud, click fraud.
Anything you can think of that makes money, these guys are involved.
It's a lot of different sorts of sinister activities that victimize people all over the world.
Cybercrime is a truly global crime, a transnational crime in nature that is different from what used to be.
There's no set boundary for where they might come from, and there's no set boundary for where they might attack. A lot of it is targeted opportunity, wherever they can find a toehold, especially if it's financially motivated.
Given the migration of so much of our important work, our personal information to the cloud, you have to have a level of commitment by a company like Microsoft to protect computer users. The Cybercrime Center is one tangible example of our commitment.
I think that we are at a critical moment in time. In part, it's because the problem is getting worse. Now, at the same time, our technology is getting much more sophisticated, and it was clear this was the time to make sure that we harness the power of that technology so that we have the most powerful ability in the world to fight crime on the internet.
Well, the Cybercrime Center is a place, a global headquarters for our worldwide digital crimes unit that is fighting cybercrime around the world. It's a place where our most talented lawyers, intelligence specialists, investigators work together here with law enforcement and industry partners to combat cybercrime and investigate real cybercrime cases every minute of every day. That includes mapping capabilities, it includes malware detection capabilities, all sorts of cutting-edge forensic techniques that allow us to detect, monitor, and investigate the cybercriminals.
No nation or no international or the regional organizations can fight against cybercrime alone. We need global alliance.
Where there are bad guys in one country doing damage in another country, our ability to have a global footprint and be able to interact with law enforcement in all these different countries is essential.
If you worked alone, what you would see is these complex networks. You would take down one site and another one would pop up. So essentially it becomes a game of whack-a-mole. Instead of doing that, we're able to work with Microsoft and make really lasting, impactful change by taking down things on a much larger scale, because they have the visibility and the expertise to do that.
It helps ensure that our customers get the benefit of all of this expertise, that they have a safer and reliable computing environment. It also enables us to do something for the world as a whole, we hope, in terms of ensuring that everybody, no matter what kind of computing device they're using, can do so with more confidence.
great. So as you can see, cybercrime is a huge business issue, not just for Microsoft and our partners, but also to you, our customers, right? And the solution is a truly cross-group and global effort We're bringing the best, the brightest and the best across Microsoft to bear on this, and we're also bringing our best technologies. Those of you who attended Zoe and Sanjay's session would have seen how we approach this from our Power BI stack, bringing in our new APS appliance, all of that. But our team of data scientists are also part of this team. Our data scientists are constantly building models, predictive models, that can detect very accurately the incidence of fraud and anti-piracy. There's been a lot of news headlines as a result of this team effort on this project, because way back in, I think, December, there's a set of headlines about 3 big cybercrime units that were busted in Asia. There was one in Singapore, another one in China and Vietnam. And we're not talking about mom and pop shops here. We're talking, about huge multi-million-dollar criminal outfits. But one of the key reasons they were busted is that the machine learning models we built actually accurately predicted, it detected these signatures as being potentially fraudulent, and the DCU team actually went after them. Now, so that's cybercrime. Next up is another similar solution, which is security. As Derek said, Microsoft is under constant attack, right? We're like the guy waving a red flag in front of a bull. Our network is being constantly attacked, even as we speak. And again, the stakes are very high. If you only use descriptive and diagnostics analysis, it doesn't get you very far in this game. And you end up in a situation where you're playing catch up, right? Because if you detect a network intrusion after the fact, well, it's already too late. You're now in damage mitigation mode, and it costs literally millions, if not billions of dollars in revenue, plus the impact on our brand, okay? And so it behooves any modern organization, any modern security organization, to try and detect these incidents, these breaches before they happen, right, so that you can actually prevent it. And so, again, our team of data scientists is on a retainer with Microsoft's global security team to detect. We use all kinds of machine learning algorithms that mine security logs on a constant basis, and they will detect beforehand when we have a potential threat, right? Again, this is an ongoing thing. And another reason why this is important is that security and just cybercrime are those classes of problems that are constantly evolving. It's very dynamic. You can't build a solution today and say, okay, that's it, job done, I can go home, right? Because the technologies are constantly evolving. These criminals are doing everything possible to outwit the vendors and law enforcement, right? So you have to, it's like a game of champion challenger strategically. You have to constantly be a few steps ahead of the criminals, right? Which is why another good reason why you need predictive and prescriptive models, not just BI solutions. If you want to be ahead of the criminals, because if they come up with any new tricks to breach your system, you want to be able to not just catch that, but build more powerful models that will fool them in the future. Okay, and now I want to spend some time and drill even further into a very interesting problem we solved for our advertising team, our online advertising team. And the problem is simple. It's a classic marketing or retail problem, which is very common. How can you detect beforehand which customers are most likely to adopt a certain product? So in our case, we're trying to find the best customers for 2 of our products, Windows Phone, just before launch, and the new Surface, right? And all we had was cookie data we collect when you're browsing any Microsoft.com property, right? So if Val starts browsing around on any Microsoft.com property, can we accurately detect if Val will be interested in any of these products? Because if you do, then you can be smarter about how you engage the customer, right? If you know they're interested in Surface, for instance, then you can start showing them a promotion you have for Surface, or the right advert to drive click-through and conversion. So to do that, we built two types of models. In the business, we typically refer to these models as customer propensity models or buyer propensity models. And it's basically a statistical model that will predict the probability that the customer will actually buy your product, right? The first model was for Windows Phone. And for that one, we struggled a little bit because we didn't have much data at all. In fact, there was no data at the time on actual sales transactions for Windows Phone because it was a brand new product. So instead, we used, as a proxy, we used their interest in the product. You know, if you've responded favorably to any of the marketing campaigns for Windows Phone, we use that as a proxy of your likelihood to buy. But that one was not very successful because we found that in the absence of hard transactional data, you couldn't accurately predict the customer's likelihood to buy. So we never put that one in production. Fine. But the second one was very, very good. The second model was for Surface. Again, it's a similar propensity model where we collected a lot of data from our web log files, and we built predictive models that accurately predicted the likelihood, the probability, if you will, that a customer will buy the Surface. This is a classic big data problem for many reasons. Volume of data was huge. The raw data itself ran into several hundreds of millions of rows, right? It's the classic cookie data across several sessions. So you couldn't process all of that data on a single database. No way, it just didn't work. Which is why we used Hadoop. And in this case, we used Hadoop running both in the cloud, so HD inside, and on premises. And on premises, we use HDP for Windows, right, from Hortonworks. And just to give you a scale of the amount of processing involved, we run our models approximately once a month, where you basically grab all the data, load it on Hadoop, and then you run MapReduce jobs to score customers based on their cookie data. And when we run that job, it's a large batch job. It takes up to 8 hours just to score customers. And this is scoring, we're not training. So it's a huge big data challenge. Then the other thing is we had a lot of fields, original variables to consider. The raw log data set has up to 600 different variables for each customer, right? So if you aggregate all the cookie data for each user, you end up with over 600 variables. Now, where do you start? You can't build a logistic regression model with 600 variables, or even any machine learning model. It doesn't make sense. So your first job, once you clean up the data, is to do feature selection. And this is one area where Derek's point is extremely valuable. Derek mentioned in our process that the data preparation is a critical part of the model building process, and that's true. In fact, in a typical project, we spend 60 to even 80% of the time on that data preparation phase. It's grunt work, it's not fun, but it's absolutely necessary, because this is where you, A, get to understand the data so that you get enough context to build the right models downstream. But secondly, this is where you start making trade-offs in terms of which features you will use to actually build your predictive models, right? So we start with 600 variables, and through several machine learning and statistical tools, we narrowed it down to just a handful, right? And the chart at the bottom of this slide shows the most important variables for this model. It turns out that these are your top predictive models that will actually predict with high accuracy the likelihood of a customer buying Surface. No surprises, you'll find, so the ones with the highest bars are the most influential, right? So surprise, surprise, you find that the most predictive variables are those ones that have something to do with Surface, right? It's intuitive. For instance, the highest one here with 30% impact is the one at the bottom that says cat Surface store. This means the user at some point visited the Surface store sub-site on Microsoft.com. If they actually visited that sub-site, then it's highly likely that they'll buy a Surface. If they had Surface or Surface Pro in their keyword search, again, it's very highly predictive. There's a high chance they'll buy the product, etc. But we found some really interesting ones, like Mac OS, right? It turns out that customers who actually visited Microsoft.com pages using Mac OS devices were actually more likely to buy Surface, right? But it takes a lot of time to actually get to this stage, to go from 600 variables down to 10 to 30, right? That's a critical part of the analysis. All right. As I said, you really want to start this process by looking at the big picture. And in this case, we took the original data, all that raw data from our log files, and we just went through different paths of analysis to understand the big picture, what's going on. On the left-hand side, we have a power map just showing on a typical, in a typical 5-month window where most of our customers are visiting from within the US. There's a high intensity there down in Texas. We still don't understand why. And then the chart on the top right-hand side is a result of path analysis. This is where we mine the data to try and understand how customers navigate around our website. So this tells you the strongest, it only shows you the strongest paths. For example, it says customers who moved from, customers who ended in the Xbox Live pages came from Xbox pages. Or customers who went to the download site, any of the Windows download site, started from the Windows pages. Then next, we did deep text mining on that data, because as you can imagine, most of the data from the log files was just textual data, right? It has a lot of details about the kind of keyword searches you did, which pages you visited, which site you came from, etc. So we did text mining, and I'll share the results with you. We also did segmentation, both on the text data itself and also segmentation on the customer. So you do data clustering to really build real customer segments, because that gives you a very good idea which types of customers are visiting your pages. And when you drill down, you'll find that all segments are not equal. Some segments will have higher propensity to buy your product than others. Okay. So that's another result of the type of analysis we do on this data. So as you can imagine, if you pull up typical cookie data, you can do a lot of analysis on the user itself. For example, what OS did they use? Is it Windows? If so, which version of Windows? We have that information. If not, is it Mac? Is it iOS? Whatever. What browser do they use? Is it IE, Safari, Chrome? We have that information. And then the other analysis you can do is behavioral analysis, where we try to understand how customers actually use the site, how they actually interact with any of our web pages and the sub-sites on Microsoft.com. So the top chart there is just a frequency chart. It shows where people spend most of their time on Microsoft.com, right? And in this case, the orange bar there on the left-hand side says most people tend to spend time on the core Windows pages, followed by Windows Phone pages, then MSDN pages, etc. The middle one has a similar picture, but this time it's looking at referrals. Where are my customers coming from? Do they come direct to Microsoft.com, or do they get there through referrals? And what this shows is that most of our customers come direct to Microsoft.com, right? Any of the pages under Microsoft.com. Next up are referrals from Google, and then we have referrals from other sources like Yahoo, etc. The last chart on the bottom is like a 2D map. It says, okay, if we look for each type of referral class, right, where do customers spend most of their time? And what we see is for the guys who come in direct, so for all direct traffic, again, they spend most of their time on the core Windows pages, and that's shown by the top, the orange bar, sorry, on the bottom left-hand side. And then for customers who visit from Google, so if you look at Google referrals, they don't spend most time on Windows pages. You notice there's no orange there, right? The highest one is a green, and that shows for customers who've come in through Google, their most favorite page is not Windows, it's actually Windows Phone pages or MSDN, etc., right? So these are just different slices you can take through the data to try and understand it. Next one is topics and themes, right? Engineering was very interested in this because they wanted to know I know customers are searching for all kinds of things, right? If you look at the cookie data, you see, I mean, there's a wide variety of interests. But they wanted to see, okay, what's the top, say, 10 or 20 themes or topics, right? And to do this, we used a text mining algorithm to try and organically create these topics. We came up with 25 different topics, and the two tables I have here show the top 5 for all searches done directly on ms.com pages versus the top 5 topics for searches done outside of Microsoft.com. And you find the topics are quite different, right? So again, it tells you, this is another hint that, you know, all customers are not the same. This is another reason to really do data clustering to get real customer segments, because things like this actually show you that these customer segments behave very, very differently, and they have different interests. Okay. And the last piece of text analysis we did was just clustering on the keyword searches, right? What are people searching for? And just like the topics, right? What can we discern from these searches? We used hierarchical clustering to boil it down to 15 different clusters. And we have two different views. The view I don't show, the view here shows the 15 clusters we got for typical Windows users. And the interesting thing about them is typical Windows users tended to search for product-related information, right? So this tells you, again, this is kind of intuitive when you step back, because if you're a Windows user, you're more likely to be a customer. You're more likely to use other Microsoft products. But when we did the same clustering on non-Windows users, we found that, yes, majority of them are searching for some product-related information, but over half of them are just searching for games, right? They're Xbox fans or gaming fans. So again, another pointer as to why you really need a robust customer segmentations. So I've talked a lot about the what and the how we did it. Let's talk about results. Why does this matter? We don't just, we don't just spend weeks throwing powerful algorithms at this thing for fun. Yes, it's fun if you like it. But the most important thing is to answer real business questions. And the question the team had here was, can you help us better target our customers? And the result is emphatically, oh yes. The models we built drove better customer targeting and also increased revenues significantly. So this, if you look at the kind of models I just went through, plus some of the other measures, actually increased customer targeting by over 5%, which is statistically significant. And anyone in the retail business will understand the impact of just a 1% gain in customer targeting. In fact, in most mailing campaigns, if you did nothing, if you just worked with one of these lists you buy from third-party providers, you end up with maybe 1 to 3% response rate, right? And the only way to systematically beat that kind of mediocre performance is to use some of these powerful predictive models. And in this case, we actually improved by not just 1%, but 5 percentage points. Then in terms of revenue, we saw a huge lift as a result of these modeling. Number one, the online advertising revenue increased by up to 19%. Then if you drill down into the revenue per 1,000 impressions, that grew by over 8 times, so 800%, and revenue per click also grew by 6 times. All right, so any questions before we move on? Okay, so I'll bring in Derek to talk about how we think about building a data science team.
Yeah, we could have chose a lot of different examples. There's just too many to show, so we chose this particular one. But the work that we're doing cross-cuts across the entire enterprise. And if you were doing the same thing in your organization, you're going to find the same need to have a team that can actually deliver this. And maybe we can, thank you, Val. So in our team, what we found out that the composition we needed to be able to support across the enterprise, we pulled, our data scientists come from academic fields of applied mathematics, computer science, econometrics, statistics, and engineering. But, and then, as I mentioned earlier, we have domain knowledge. You have to have that business side of knowledge and be able to talk that language and understand how the business thinks in terms of how they view models and how they should be developed. So, of course, we right now on our team have people, again, that come from financial service, telecom. You can read that. And then in the domain experience area, we specialize internally, and these seem to be on the Pell curve, the ones that are high demand internally within our organization are forecasting models that do fraud detection or credit modeling or predictive modeling, of course, and sentiment analysis, clickstream data analysis, and design of experiment predictive, the standard data science work that most data science teams would have a need for. It's a team sport thing, and the team that we have is roughly, I'd say, 12 to 13 data scientists. We have other data scientists that we can draw upon in our partnership groups that we have, and then we have some vendor backfill that we actually use to help us in some of our data science work. And in IT's, our data science team, we staff it all with FTEs. We staff it all locally inside Microsoft, primarily because we're dealing with high business impact type of data, stuff that we really don't want to have surface outside. It needs to be done internally. When it comes down to lower business impact work or medium impact work, we do medley. We do a little bit of medley in our data scientist teams. But primarily, this is how we compose. And I'd be glad to talk to anybody afterwards if you're thinking about how you would like to structure your data science team or what thoughts you're doing or where you're at on that journey to give you some of our insights. When we think about the roles of a data scientist, this one's a funny one because the reason why this slide exists is we had early on a lot of our business leaders would come to us and say, "Oh, I've read this thing. You know, there's this Harvard business has come out and said data scientists are the sexiest career to be in." And I said, "That's because we deal with models all the time." That's a bad joke. I know. I know. Thanks. I wanted to try it out, so I did. All right, I went for it. All right, so they say, give me a data scientist. Can I have a data scientist? And we have to have this conversation that that unicorn doesn't exist. I mean, what we have found, though, internally is that there's these 6 facets of what the ideal data scientist is and what we find that we need to deploy when we go into solving a data problem insights. And we expect to have domain knowledge brought to bear in a customer. Well, let's start with the customer and the partner. side, because this is the fascinating part. We have a lot of customers come to say, I have a big data problem. I have a big data problem. We need data scientists. I just read in the article that this is needs solved. So we have a process, like we said, that project discovery process. And a lot of times we find out they don't have a big data problem. They have a bad data problem. And it requires a different kind of thinking and approach to solving the problem. So we ask that all of our customers right up front, so that there's no confusion, because we cross-charge internally. We are a self-funding group inside IT. We're actually a profit center of sorts, in an internal sense. So we actually don't have a lot of time to go do search for God type of experiments. And so we actually are trying to solve real business problems. And we ask our customers that come to us that they've actually done that due diligence and actually have thoughtfully worked through the problem description that they're trying to solve, or what they think, and some options that they've weighed that, and that they're willing and open to have a dialogue with us and between us and the business. And that they are receptive to the conclusions we get. We do have, even internally, some leaders that have actually, they've been working so long, things aren't going right, they want to see how they can improve the business, and they believe that the instincts and the decisions that they've made will be borne out by the data scientist showing them. So we want to have that conversation. And sometimes, like a doctor, the information that we get through our diagnosis of the situation may come out that it's counter to what they expect to see in the data to support their assumptions or their gut instincts and decision making. And that's where we have the kind of, we say ethical discussion considerations, but it's basically being open to having that conversation and hearing it. They can always work with other data scientists to try to see if the answers that we're giving them, find that second doctor, if you will, when you don't get the answer that you're looking for. But for the most part, those leaders do respect us. They do come back, and on those occasions when it's rare when that does happen, and they actually start to embrace the insights, because they start seeing, as they apply these models, they start delivering the insights that are not really what they thought they were, and then they change their business models. And in that sense, that's when we know we've done our job, and that we actually, when they come back and actually continue using us to do additional models, we see that that's just a huge win. It's a really good feeling. Scientific method, all of our data scientists are all well versed in the scientific method. We actually do apply that. Everybody on the team, the data scientists all have some degree of in-depth math and statistics background. Advanced computing and data management, that's a must-have. All of our data scientists do code, whether it be in R or C# or C or Python or open source. It's just a requirement. And like I said earlier, they're all required also to get their hands dirty and to get into the data. You just have to do that. Intellectual curiosity and critical thinking. I think everybody in this audience has that. Otherwise, I don't think you'd be here. But that is a core thing that just has to be in you to go and do that. And then lastly, being able to visualize and communicate the insights and the results. And we try to do, that's not just the visualization of showing it through our Power BI and our technologies, but it is also in just being able to have that conversation with the business user to connect and to help them appreciate everywhere from going and saying how the models are created, but more importantly, the business, being able to talk to the technical folks and the engineers and explain it to them, but also be able to go up and be able to talk to the C-suite. C-suite, is that right? Yeah, okay. Leadership teams. So it's really a dynamic here, and we have a lot of slides, and I would have loved if we'd had more time to show how that actually works in that process, but this one really sums it up. And I would say if anybody has any questions on this, feel free. We can talk also about that. And now I'm going to hand it back to Val, who's going to finish up.
So thanks, Derek. Again,
Val.
So just to wrap up, I want to share some best practice we've actually learned. As Derek said, our team has been going for over 4 years now, and we have a set of collected best practice, starting with the first one there. One of the key things we've learned is that data science is a team sport. It's not an individual sport, right? Why? Because, number one, if you look at the set of the core 6 skills Derek just showed in the previous slide, it's very hard to find that in one person. And that's why you find employers typically fail to recruit good data scientists if they're looking for that classic unicorn, right? If you want someone who's a PhD in math or stats and he's a deep programmer and all that, plus he or she has domain expertise and all that, I think you're looking for God. But and so that's one reason why you need to hire not just one person, but a team of high impact people who can complement each other. Now, the second reason that's really important is one of the things we also learned is the real magic in data science happens when you bring people together from different disciplines, right? Because if you only have one view of the world, say, okay, if you look at traditional industries who've done predictive modeling for a long time, like financial services, right? I worked at Equifax a long time ago. Folks like that, banks, banks and insurance companies, they've always had data scientists, right? Because they've always had, their core risk analysts are actually statisticians. Some of them are PhD statisticians or physicists. But the thing you miss if you only hire from one discipline is those people have a certain lens, a certain intellectual framework, and the thing you really miss is all the value, all the benefit of big data. Because if you only hire PhD statisticians or mathematicians, well, they don't understand. They may not even know of the latest improvements from machine learning, for example, because machine learning has actually solved a lot of the issues, the taxing issues that faced statistics for a long time. We now have very, very powerful algorithms from machine learning that you will completely miss if you only hire statisticians. Likewise, if you only hire your PhD machine learning people, and you don't have a good bench of mathematicians and statisticians, it's too easy to to end up with the wrong conclusions, because you can throw a very powerful algorithm at a ton of data and get results that could be exciting, but they don't make any business sense, or they may not be repeatable. Why? Because you did not follow the rigors of statistics, right? Because even for large data sets, a lot of the core foundations of maths and statistics still apply. A lot of the core foundations of just basic enterprise data architectures still apply. For example, data quality is still critical, because the old adage is still true. Garbage in, garbage out. I don't care what algorithm you use. Right? So it really, there's a lot of benefits you get when you bring people together from very diverse academic backgrounds, industry focus, and also life experiences. Honestly, I feel so passionate about it because I've lived it. It's very hard to understand it if you haven't been through it, because people bring very, very different backgrounds that can really light up new scenarios for you. The second learning we've had is how best to organize your team of data scientists. We have questions very often from CIOs and other CXOs about, okay, look, we're trying to hire data scientists, but let's say, okay, we're still struggling to find them because they're so rare in the market. But when we do hire them, how should we organize them? Should we just set them up in a single centralized team to serve the whole organization? Or should we embed them in lines of business? Our experience so far suggests that the best organization is a hybrid one. You need a centralized team of data scientists like our team, that can collect and share best practices across different verticals, across different lines of businesses, right? But at the same time, you don't want, if that's all you have, it's too easy to create an ivory tower, right? And then you become ineffective. So that's why we feel it's also important to have data scientists embedded in your line of business, because these people work side by side with your SMEs, with your business analysts and the decision makers, right? So you're far more effective that way. And the other thing is they also learn and bring back new learnings into your organization that you can share with the rest of your data scientists. Then the last one is about how the relationship between your data science team and your BI team, right? The ideal thing in our view is if you really want to do really good analytics, then you want to staff up with capabilities across all of those 4 buckets that Derek pointed out earlier. You really want to have a capable team that can do everything from descriptive, diagnostic, predictive, and prescriptive analytics, right? And typically, the first 2, the descriptive and diagnostic analysis, tends to be done effectively by BI teams, your BI and data warehouse teams. And then the prescriptive and descriptive is done by your data scientists. But how should you structure those 2 teams? Should you embed your data scientists in the BI org or vice versa? We've gone through a lot of first-hand learning on this journey as well, because within our Microsoft IT team, we have all kinds of teams. We have the enterprise teams that do all the data governance and enterprise-wide data architecture, right? We also have our data warehouse and BI teams, and then you have our team of data scientists. And the lesson we learned is that we work best when your enterprise team provides the data to everyone, right? I mean, their job is to do the enterprise-wide data architecture. And then to have your BI team sitting side by side with your data science team. Because that way, these guys you have better division of labor for starters. Your BI team can continue doing all the things they do very, very well and with a lot of agility. But your data science team can also focus on the latter 2. One of the risks we find of embedding your data scientists in a BI team is that you can easily get into a situation where you're underutilizing your data scientists. Why? Because, at least in the cases where we've seen customers do that, the data scientists are typically not well understood by the BI organization. I mean, we've seen extreme cases where, unfortunately, PhD data scientists basically spend most of their time creating reports. That's a huge value sink to the customer. And that's why we recommend having these 2 organizations as peers. But you still need the foundation, which is your enterprise-wide data architecture team. Okay, so just to summarize, we briefly introduced our data science team at Microsoft, spent some time going through some real-life examples to show how we're applying advanced analytics to solve real challenging business problems for Microsoft. And we talked specifically on cybercrime, security, customer-targeted models. There's a whole lot more examples we could cover, but unfortunately, we only have 1 hour. We're available to answer any questions you have after this. We can go into more details. And the last thing we touched on is the lessons learned on building data science teams. So we're right at time. Thank you very much for your time and attention. Please take the time after this to fill out the evaluation forms. And a little bird tells me if you get very, very high scores, you're more likely to win the prize. But thanks. Any questions before we wrap up? Sorry? Are your slides available? Yes, they are. Are the slides available? Yes, they are after this. Yeah. Any other questions? All right. Thank you very much. Enjoy the summit.